Hello, everybody. So this video, what we're going to be doing is we're going to be looking at this lab right here, Lab 13B, Tetris Lab 1. Now, before you try to do this lab, you should watch this Lecture 2 here. Lecture 2 in week 13 that says that the topic is Java Classes Fundamentals. So Java Classes is going to be the material that's in next week's Zybooks. So this is a little bit early, but you need to at least be somewhat familiar with the concept of Java classes before you can even start this Tetris Lab number 1. Now, with that said, we'll go ahead and get started. I'll open it up and we'll take a look. So we're going to be trying to program Tetris. Now, with the amount of time that we have left and the amount of other stuff that we need to do, we're not going to be able to go like super slowly, which means we do need to get a fair amount of stuff done every time we're doing a lab on this Tetris project. And so this project is going to um, give us the bases of our Tetris pieces all in one um, shot here. Although, we'll have to come back in next week and the week after and kind of fix it up a little bit. But we'll get some stuff on the screen today, and that should make us pretty happy. Um, it's pretty satisfying to see stuff get going. And yeah, so let's go ahead and get started. So I've got Eclipse open right here. I'm going to go ahead and I'm going to make a new project. So I'll just say Java project. I'm going to call this Tetris. I already have down here, you might see it, Tetris test 1. And that's actually where I originally programmed this before I made your lab for you. But I don't want to delete that. So I'm just going to make a new project. I'm just going to call it Tetris, and I'll probably delete it next week and do it again. But there we go. So we have Tetris. And once we have the Tetris project, we need to create 2 classes. So if you haven't watched the lecture on classes yet, then this might not make perfect sense. So what we need to do is do this. So we're going to go File, New, Class, and this is going to be our main class. And so I'll name it main with a capital M. This you can name it technically anything, but I named it main when I wrote it the first time, so I kind of have to keep that. So main, capital M. We don't really need to check this box for public static void main because we're going to be copy pasting this entire class. We're just going to use the code that I put in the lab. So it doesn't really matter if I check that or not, and then we'll hit finish. Now, as usual, when we do this, you'll see down here, it says main.java, which matches our main here. But we also need to make a second class. So before we do anything else, we'll go File, New, Class again, and we're going to make a class for our pieces. So we'll call it piece. We won't call it pieces because if we called it pieces, that would sort of imply that we had more than one piece. And we might actually have a class that does that, but not today. So we'll hit finish. And now we have 2 classes. So down here, you'll see that in our one project called Tetris, we now have a main.java and we have a piece.java, 2 separate Java files. And they're both open in the editor right now, and they're both, pretty empty. So what do we want to do? Well, we'll go over here. We'll take this main class. So it says part 1, the main window. I'll just copy paste this. So I'll have to kind of drag down. There's quite a bit of code in here. This code is not actually going to be used for the game. I'll delete what's in here. So empty file now. Paste. This code is not going to be used very long. This is kind of just sample code that's going to display some stuff on the screen for us. And when we do that, then, I mean, that's its only job. So it's not really a Tetris game. It's just kind of displaying the pieces for us to look at. Now, this is not going to run, right? You'll see there's all kinds of errors here. A lot of the errors are related to you see it says pieces dot add, and that's going to be a list of our pieces. And we got problems on all those lines. So this code does not do anything yet, but I copy pasted it and I saved it as main.java. Then we need to get started writing our piece class where all the work is for, this lecture or this lab. So it says step one, the skeleton code and class fields. So it says we need to start by defining the variables fields that every Tetris piece needs to know about. And it says copy the following skeleton code into your piece.java. So I will select all this, copy it, go to piece. Make sure you delete what's in there. Otherwise, you'll have some repeats of a certain line, and that'll cause you issues later on. So paste this and save it. Now, again, this code does not run. If I try to do run, it's just going to tell me that there's errors. And that's kind of one of the challenges of this right here is that we don't have a working project yet. So it's hard to test this as we go. But I couldn't think of another way really to do this and have the main already written for you. So that's just the way it is. So let's go back to piece.java. Now, one thing you'll see up here is there's not much code in here yet, but the code that you can see, it says public static enum piece type. And so an enum is just a list of basically keywords, and the keywords are piece type, and these are our Tetris pieces. Now, you might think of the Tetris pieces if we can like Google like Tetris, right? And find Tetris. That's not what I wanted, but the pieces you might call these like you might call this an L or something, and or you might call this one an L. You might call this like a J. I think they call this one like a Z. Or no, this is an S. This one's a Z. This one, you might call it T, etc. But um, if you actually look up the piece names, Tetris piece names, it turns out that they have very stupid names. So um, the names are, we can find them lots of places, but here they are. So apparently the names of the Tetris blocks are Orange Ricky, Blue Ricky, Cleveland Z, Tiwi, Hero, Rhode Island Z, and Smash Boy. And those come from, I think they come from the Nintendo manual. So here's like an old manual for Tetris, and that's where they were. So that is what they call them. You can find the same names all over the place. And here we go. So that's what we're going to use because it's funnier than the other possibilities. So we'll do it. So these are the names: Orange Ricky, Blue Ricky, Cleveland Z, Rhode Island Z, Hero, Tiwi, and Smash Boy. Now, our class can have what we call fields. So fields are just variables. Fields are just variables. And you don't really get to make a decision here because I already made it for you. But normally you can decide on what kind of fields or data you need. And so our Tetris pieces, they need, as it says here, two integers named x and y. So we go int x comma y, or they could be on separate lines, but I'll just put them on the same line. Now, again, make sure you watch the video on classes, but we don't want to just say int x comma y. We want these to be private, and we, by default, make all of our variables private when we're making a class. That's the standard thing to do. So there could be things that are private and things that are public, like public static enum, but these are going to be private, which means they're only accessible here inside of this class. So we did number one, two integers named x and y. I'll delete it. Number two, integer named orientation. Okay. Private int orientation. So we're just going to add all these. Add an integer named block size. Okay. Now, could we have put these all on one line because they're all integers? Absolutely. But I'm doing it line by line. What is block size? It determines how big each square is drawn. Actually, now that I think about that, that makes me think that I probably should not be deleting these as we go. But maybe I'll paste them back at the end. Um, a piece type named type. So now we get to use this thing. So we'll say private. And once you define a piece type here, then you can use that as if it is a type, just like int. So private piece type, and we want to call it type. Okay. That's going to store which block we are dealing with. A Boolean name destroyed. I don't think we use this one at all, actually. This is leftover code from when, before I programmed Tetris here, somebody in the face-to-face class asked if we could program a doodle jump, and I didn't know what doodle jump was, and so I had to code that up first, and I think we made this. And so I think there was a field called destroyed for the platforms that might be destroyed. But we're not doing that, so goodbye, doodle jump. Um, but I left it in here. I don't know why. We may never use that. But a Boolean called destroyed. A color named color private, color, capital C, called color, lowercase c. A 3D integer named array 3D. Now, when we learned about arrays, we learned that, like if you do int, that's an integer. If you put square brackets after it, that's now an array. If you put two square brackets after it, that's now a two-dimensional array. And you'd have to access it with an X and a Y coordinate or an I and a J coordinate. But we're going to use a 3D array, and we're going to call it array 3D. I'm calling it array 3D because, well, I kind of want to make sure we know that that's what it is. So it's an array. It will hold data or our shape. And then finally, I want a name. This was the last thing I added, a string called name. And that's going to be like the human readable name for the piece. We may not use that for the game. We may or may not, but um, it's here anyway because in this kind of first class that we're writing, um, when we get the pieces drawn on the screen, we'll actually draw the name too. So we're going to use it. Okay. So, oops, I deleted too much. So the fields are just variables that are inside of our class. So every piece has X and Y, orientation, block size, type, destroyed, true or false, a color, and an array, and a name. Cool. What is next? So now the next thing is going to take some typing and a lot of copy pasting. So it says Tetris pieces rotate. To handle this, we're going to be using a 3D array. Now, what does that mean? Well, so if you had this much right here, that part that I highlighted, that is an array, a one-dimensional array. If I have this much that I've highlighted, that is a two-dimensional array. Like you could specify the position by what row you're in and then what column you're in, right? So you would need what row, what column. But if you group a bunch of those together, in this case, four, or I'm only highlighting three, but if you group several two-dimensional arrays together, then now you have a three-dimensional array because you have a group of two-dimensional arrays. And so what these are corresponding to is kind of this, well, an orange Ricky. So what's an orange Ricky? Let's look at our picture again. What picture did we have that was good? Here we go. So an orange Ricky is this shape, right? And the way we're going to represent it, you can see right here, right? You see one, 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 right? This and this is our L shape. And what we're going to do when we go to draw the shape is we're actually going to draw exactly what you see here as square blocks. So if there's a zero here, you'll leave it empty. And if there's a one, you'll fill it in with a square box. So when we draw this, it's going to draw this kind of orange Ricky shape. But in Tetris, the pieces rotate. I'm going to assume you're familiar with Tetris. And so, this is the orange Ricky in one orientation, but if you were to rotate it 90 degrees, then this is what orange Ricky would look like, right? Like here, 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 and here. And if you rotated it 90 degrees again, it'd be here, 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 here. And if you rotated it another 90 degrees, it'd be here, 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 and here. And if you rotated it another 90 degrees, you would be back at the start. So all of this is basically a three-dimensional array defining all the different ways that Orange Ricky could look. Um, and putting it in this format will allow us to, the same code that draws Orange Ricky will be able to draw Blue Ricky or Cleveland Z or Rhode Island Z or Hero or Tiwi or Smash Boy, the same exact code. Um, we won't have to have special cases in the draw statement that says like, well, if the piece is Orange Ricky, this is how we draw it. And if the piece is Hero, this is how we draw it. We'll just have to draw this array and it'll automatically look the way that it's supposed to look. And that's why we're doing it. Now, your job is to implement all of these. So like if you were to copy all of this, for example, and just go down and right below it, you could just change the name to, instead of Orange Ricky, we could call it Blue Ricky, for example. So just change orange to blue. And what's the difference? Well, Blue Ricky is just the one that, looks, it's like the mirror image, right? So what you would change here is you'd say, okay, well, this is the this is the orange Ricky, so I would take that and I would move that over here, right? And then now it's the blue Ricky. But you have to do that for all the shapes. So you'd have to take off this, put that up here, and then this uh from here, and I think it'd be here. Oops, here. And then the last one would be, I think, here, like that. And so I think that's the Blue Ricky or close to it. But I won't commit to that yet because first of all, I think I wrote some of the others for you already. So we also have Smash Boy and Hero and Tiwi already written. So let's just get those. Oops, hard to copy paste these. Although they're indented a little bit wrong here. Don't know if how hard that will be to fix. It's also, come on, scroll. Okay. So I'll copy all that and I'll put it, I think, right here. Okay, so what do we got? Let's look. We have Orange Ricky, put a space, Smash Boy. Smash Boy is uh, this one. Of course, you can see it there. And Smash Boy, when you rotate it, doesn't actually change, right? So Smash Boy is just here, and then the same even when you rotate it. Hero. Now, something that's useful when you're doing this, by the way, is if you Google Tetris rotation systems, what you'll find is kind of the official way that these rotate. And what I copied was the one listed as super rotation system because they're all a little different. And it says super rotation system is the current Tetris guideline standard for how tetrominoes behave. Tetrominoes is like dominoes, but tetrominoes. Um, and it says, how they work. And so I tried to copy this. It's not like you might think that it doesn't really matter, and maybe it doesn't, but I'm just kind of just see if I can put this on the side here, and then let's get eclipse and put eclipse over here on the side, just to show you that. When I was trying to copy this for Hero, for example, um, this box here can be represented like as a 4 by 4 box. And you can see that this blue line is actually slightly above the center, right? So that's why I put it here. And this one right here, which is rotated 90 degrees, is slightly to the right. And you'll notice that I put it here slightly to the right. And then this one, if you rotate it another 90 degrees, is below the center. And you'll notice that I put this below the center. And then finally, this one here is to the left of center. So I put it to the left of center here. And so that's what I copied for the ones that I did. And so when we did Orange Ricky, the first one, notice that except for like the one that's a line takes 4 by 4 spaces, but all the others can fit in a 3 by 3 box. And so what I did was just assumed that the top left corner was the top left corner here. So when we do Orange Ricky, then right, it's blank, blank, orange, and then a row of orange. So blank, blank, one, and then a row of ones. But then this is always going to be zeros on any of the others because we don't need 4 by 4 for any of these other shapes. So anyway, Orange Ricky, top one's here. Um, then if you rotate it, you get this one, which is here, 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 here. That's that. Then you have this one, which is drawn here. And then you have this one, which is drawn here. Smash Boy, we already talked about, where it's just the same every time. So did that. Hero, we already talked about. Tiwi, we didn't talk about, but it is down here. So you can see that we start with, you know, one block over is where it starts. So one block over right here. And then there's the T. And then if you rotate it, you get this. 3 1s and a 1. If you rotate it again, you get this, which notice it's blank on top and it's down 1. And that's what we have here, blank above it and then down 1. And then this here, this here. Now, we just tried to do Blue Ricky. I think I did that one already, but we can check to see if we got it right because we didn't look at this picture. So top left corner is where it starts. Looks like we got it. And then when you rotate it, it's like this, and there it is. And then it's like this, and then it's like this. And then finally, it's like this, and finally, it's like this. So it looks like we did Blue Ricky okay. So we did Blue Ricky now. We need to do Cleveland Z and Rhode Island Z. So we have to do those ourselves. So what we have to do is copy one of these, like maybe this one right here, Blue Ricky, hit enter, paste it. Now, we can't have the same name, of course. So what one are we doing? We're doing Cleveland Z. So let's change this name here to Cleveland Z. And yeah, so which one's Cleveland Z? So let's look it up again. Cleveland Z is the one like this. So it's the mirror image of Rhode Island Z, and it actually looks like a Z. Okay, so which is it? Where are we? So this one, right? So this is the Cleveland Z. So we're trying to do this shape right here in the upper left. So I think I have to change this to a 0 and this to a 1. Oops, 1. So 1, 1, down, 1, 1, 1, 1, down, 1, 1. Cool. Then we have this. So looks like do that. And then that up, over, up, over, up. Then we have this one, 2 down, 2 more. So 2 down, 2 more. So this should be a 0. And then over here, it's down, left, down, down, left, down. Now, part of the reason I can do this relatively quickly is because I've already done it. So, the first time I was doing this, I was looking at these pictures carefully and, thinking a little bit harder than I am right now. So, copy this, paste it again. And this time, oops, it's supposed to be Rhode Island Z, which I can copy paste or just type it. I think it's like that. And Rhode Island Z is this green one. So it's kind of the mirror image. So you'll have to change a couple things here. So it looks like 0, 1, 0, 1, right? Over, up, over, up, over, then down, right, down. So that's going to be down, right, down. So like that. Then we've got this kind of S shape. So we do that. And the consequences of not getting this right is just that the shape will be drawn wrong. And, we'll fix it when we see it. So if we do mess it up, it's not a huge deal. And then we have this one starting in the upper left corner. So we have 1, think like that. Ah, down, over, down, down, over, down. Um, Yeah. And you can notice that like this shape right here and this shape right here are the same, but this one's starting in the top left and this one's kind of moved over one. And I think they actually describe why that is the case here. If I back up and if you're curious about Tetris history here, it'll say when unobstructed, the tetrominoes all appear to rotate purely about a single point. Um, It is a pure rotation in mathematical sense as opposed to the combination of a rotation and translation found in like the Sega rotation. So like when you look at this, right, and like this one right here is the same as this one right here, but this is actually down by 1. And this one right here and this one right here are the same, but this one's kind of moved over to the right by 1 compared to this. And they're saying that it doesn't have to be that way, and some of the others like this Sega rotation don't do that. And is that true? I mean, I don't know. Let's see. Yeah. So like you'll notice that here, like this one and this one are like literally the same, and this one and this one are literally the same. And like the vertical, like the long block only has 2 states that are different, whereas this actually has these all 4 are slightly different. And so, it could have been either way, and both of them make Tetris work, so it's not like an issue. But I just chose this one to copy because I didn't know what the right way was, so I looked it up. Cool. So anyway, I think we did them. If we didn't, we'll find out when it draws if we made any mistakes. So mission accomplished. What's next after that? So step 3, the constructor. Now, every time we make a piece, you call what they call the constructor for the class. And so when you make a new piece, you have to set all the variables to something. And so this is an example of a constructor, which again, this is why you have to watch the lecture on classes before you look at this. But I just pasted it. So what a constructor is, and maybe I'll kind of type a little bit first. What a constructor is it's a method with the same name as the class. So this class is called piece. So like this is what a constructor looks like. However, we should label it as being private or public. In this case, we want it to be public. And also, when we make a piece, we want to be able to put it in a specific location, right? Like when a piece comes to existence, we want to set its X and Y values. And also, when a piece comes into existence, we want to be able to set what type it is. So rather than starting from this, we'll start from the code that's given here. So we're going to have an X and a Y value come in, and also the piece type is going to come in. And our job here is just to set all the variables. So when you remember back up to the top here, where we were told to include all of these variables, we need to make sure that we fill them in. So we need to fill in the X, the Y, the orientation, the block size, the piece type, whether or not it's destroyed, what color it is, and which array 3D it is. Now, the array 3D is just what we were just doing. So the array 3D is like just what piece it is in terms of what to draw. So come down here, and our job is to set all these things. So the X and the Y values that come in, we want to set the X and the Y values here to be the X and the Y values inside of the piece. Now, that's really loud. Um, this might be a little confusing terminology here, but like maybe I'll change it just momentarily. Like I could call these like the NX and the NY, and then I could have said X equals NX and Y equals NY. Um, when they labeled them as X and Y, then we're reusing variable names, and that's what makes this confusing, like this. And so this X and Y here are not the same as the X and the Y that are up here. And so the word this dot is how you say we want to set the variable X in this class equal to X, that input right here. So that's why it's a little bit weird. Again, it's kind of learning what classes, how you do classes. But we're going to set the X value, we're going to set the Y value, we're going to set the type. All those are coming in from when we create the piece. When you create it, it should not be destroyed. So destroyed is false. The block size, I'm hard coding this for now. Um, but this would be for, what if you make the blocks bigger or smaller, right? This is how many pixels it is. So right now we're just going to make a block 40 by 40 pixels. Orientation. The orientation is which of these four states we're in. So like this is orientation 0, orientation 1, orientation 2, orientation 3. So we'll just start it in orientation 0 and a color. Now every block can have its own color, but I just fill it in with gray to start. Okay. And then we have this big switch statement. So based on what piece we are, we have to do things slightly differently. And so basically what we're doing is we have a switch statement, which is basically just like an if else, but if else if else if else if else if you have a lot of options, a switch statement might be shorter. So I'm using a switch statement. And what this is saying is if the type, right, the type that's being we're supposed to be making, if the type is Orange Ricky, then the array should be Orange Ricky. And down here, the name should be Orange Ricky. And the color should be whatever color you want that to be. So I think this is actually an orange color. Um, and, the rest of them are just similar. So like piece type TWE, array 3D should be TWE. The color is whatever color you want it to be. The name is Tiwi, and then break. And you do this for all the pieces, right? So Orange Ricky, Tiwi, Hero, Smash Boy, we have other cases. So, right, you can just paste this 3 times, but then each of these 3 times needs to be, what they are. So, like, for example, instead of Smash Boy, blue Ricky, and then this should be blue Ricky, and then the name should be blue Ricky. And then we have to pick a color, but we'll come back and pick a color in a minute. What are our other choices, right? So you can look up here and see. So we did Orange Ricky, we just did Blue Ricky. I think we still have the Cleveland Z and the Rhode Island Z, right? Those are what's left. So let's just copy Cleveland Z. Save yourself a little bit of effort by copying the name, so then you could paste it, and Cleveland Z. And then the other one way up here is Rhode Island Z. Rhode Island Z. Rhode Island Z. Rhode Island Z. Okay. So that's all the cases now. I might have just deleted something that we needed. Yeah. No. Okay. Wait. Oh, there's one right there. Okay. I thought we were missing curly brace. Uh, Maybe I'll make that indent properly. Okay. So, all right, cool. That's the constructor. But we didn't change any of the colors here. So if you do want to change the colors, these colors are being specified in hex codes, which are commonly used on the internet. And so if you go to like any kind of search engine here, and if you type hex code color picker, you can find, oh, we're in images, but let's go click all here. And there's a lot of these color pickers. And if you do this on Google, it'll actually just, Google has one. And so you can use these like sliders here and you can pick out exactly the colors that you want. So it doesn't matter what color you make them, right? It doesn't affect the game. So like if you look and you see that in the picture, uh, I think this is Blue Ricky. Blue Ricky is blue, right? So you could use the color picker and say like, what kind of blue do we want? You can go, that's a nice blue. So you do that and you just copy this. There's even a button to copy it. And then you come over here and in Blue Ricky, you can just delete the color there, leave the 0x, and then just paste that color. And so you can do that for the others too. So it doesn't matter what colors you pick. I think the red was the Cleveland Z. So maybe I'll just do that. Again, you don't have to. You could pick pink if you want. None of them were pink. Maybe we'll do this. Maybe this is what we'll do for uh, Rhode Island Z. So copy that. Actually, I can just click the button. Um, I said Rhode Island, I think, but that's Cleveland Z. And then what's Rhode Island Z supposed to be? I think it's green. So let's just pick a green color of some sort. Again, you don't actually have to. I like that one. Copy it and we'll paste it there. Now, if you left the color off on any of these, what'll happen is it'll just be gray. So whatever. Uh, okay, that's the constructor. So be careful you know where that ends, right? It's kind of hard to get it all on the same screen, but like if you You'll notice if I put the mouse cursor there, then it highlights this to tell me that's the end of that constructor. So what's next? Back to the lab. Getters and rotation. So in the lecture on classes, or the first lecture on classes, we'll talk about setters and getters. And so getters are going to be functions or methods that they just return the variables so that you can access them from outside the class. So if you remember when we created all of our variables, they were all private. And so if the main method needs to know what the X value is, you have to call a public method. And they're all really simple methods. So it says write out 4 methods that return the values of our private fields. So like X and Y are integers, right? So scroll all the way down here, and I guess we are, where are we? Here. You go public. We need to return an integer. The name of the method is getX. And what does it need to do? It just needs to return X. And so the getters are this simple. They're all like this. So we were supposed to do get X. We're supposed to do get Y. What else do we need? Get block size. Okay. Copy the whole thing. Change that to get block size. Is that the right way? Yeah. Capital B, capital S. Block size. You have to match the name of the variable up here, of course. And then get name. Now, the name's slightly different because when you do get name, right, you go get name and you go return name, but the name is not an integer, which is why you have an error there. The name is a string, so you have to change the return type to string, and the error goes away. Okay, so our class needs to have these. What else do we need? Rotation. Now, this is a little bit, I won't say complicated, but rotation, I'm going to copy this little method called rotate right, and it looks like this. So here's what needs to happen. We have the number here is the rotation. So you have rotation 0 is the first state. And then if you rotate it 90 degrees, that's rotation 1 or state 1 here. And if you rotate it again, we need to go to orientation 2, which is this. And if you rotate it again, you need to go to rotation 3, which is this. But if you rotate it again, it needs to go back to 0, right? So you go 0, 1, 2, 3, back to 0. So it should go 0, 1, 2, 3, back to 0. 0, 1, 2, 3, back to 0. And you could implement that in a couple lines of code like this. You could implement it this way. Orientation equals orientation plus 1. That will rotate it once, but then it might go over 4. So if the orientation, uh, let's say if it's 4 or greater than 3, maybe, if it's greater than 3, we should set it back to 0. So that will go 0, 1, 2, 3, and then when you try to go up to 4, it'll end up getting set to 0. But this right here, where it goes 0, 1, 2, 3, 4, and then after it hits 4, this if statement sets it back to 0. Um, it turns out that that's actually the same as if you just take the orientation, add 1, and then divide by 4 and get the remainder. Because when you get the remainder of something divided by 4, the possible remainders are 0, 1, 2, and 3. And so this just will work. And it does the same thing as that if statement. So it's perfectly okay to do it the other way, but this is the simplest way of doing it. Now, after that, it says below is the code to rotate right. It uses the modulo operator to ensure that the orientation stays between 0 and 3. Paste this in. Then write rotate left method. And then it says hint, instead of adding 1, add 3. Um, it's literally that simple. Um, rotate left should, instead of adding 1, you add 3. Now, the reason for that is if you think about it, let's look at a picture actually. Let's imagine you're right here. If you rotate this clockwise, you're going to go from here to here, right? And if you rotate clockwise, you're going to go from here to here. And if you rotate clockwise, you're going to go from here to here. And if you rotate clockwise, you go from 3 back to 0. Um, so clockwise is just forward here. Now, to rotate left or the other way, counterclockwise, if you take this and say, well, which one would be rotating left? It wouldn't be this one, right? It would be backwards. So instead, you'd go from here all the way to here on the end. Well, that's going from 0 to 3, which the code we just did will add 3. So that would go from 0 to 3. Um, if you wanted to go from here and you want to rotate left, then it needs to go from 1 back to 0, right? But if you add 3, 3 to the right is 1, 2, 3. So 3 to the right gets you here, but 1 to the left also gets you here. So from this location, 1, 2, 3, or backwards by 1. So the point is forward by 3 and backwards by 1 are the same thing. And so I might have said that wrong. Forwards by 3 and backwards by 1 are the same thing. So like this plus 3 here is the same as if you did minus 1. But we can't do minus 1 because if you did this kind of, this would allow negative numbers and you'll get an error because we're trying to access an element from an array. And the indices for the array have to start at 0. They can't be negative. So subtracting 1 here won't work, but adding 3 will work. And this is just the simplest code you can do for this operation. So rotate right is clockwise, rotate left is counterclockwise. Okay, what's next? The draw method. Finally, we need to draw the piece to the screen. Now, this is a little bit complicated to look at, I will admit, and we will talk about this more when we're drawing other stuff on the screen. But basically, what's happening here is when you do area 3D orientation, remember the orientation is which place we're in. So like if the piece is Orange Ricky, this is orientation 0, orientation 1, orientation 2, orientation 3. So the first thing we're doing is we're getting the correct thing to draw. So we'll either draw this or this or this or this. So the 2D array is one thing from the 3D array. After we do that, we'll set the color to whatever the color is supposed to be. And then we're going to start drawing the block at the correct location. Because remember, the X and the Y coordinates are where the block is supposed to be, because we can have a block in different places on the screen. So you're going to go from the location, which is going to be, I think our what's it called? Our window is going to be 10 blocks by 20 blocks right now, 10 blocks horizontally and 20 blocks high. And to get it in pixels, you'll have to multiply the number of blocks by how big a block is. And that's going to be the top left corner of your shape. So this is the top left X value, and this is the top left Y value for where we want to draw our piece. And then in order to draw it, you have to go through every row, first row, second row, third row, fourth row, every column, first, second, third, fourth. In terms of index, it's 0, 1, 2, 3, 0, 1, 2, 3. So you have a double for loop that goes from 0 to 4, 0 to 4. And then if the if there's a 1 in the array, we are going to draw a box there. So literally, we're going to be looping through this array, and every place where there's a 1, we're going to draw a colored block. So we would be drawing colored blocks here and up here. And if there's not a 1, we're not going to draw anything. And that is all this code does. So if I copy this, go down here, and let's say right under the rotate left, we paste this. And when we do, I feel like this doesn't have any red X's left. And over here, I don't think this has any red X's left. And so I think we might be done. So let's just see if we're done. So with all this done, I'll scroll through it slowly actually once. So um, we have our variables, we have our shapes in terms of arrays, a lot of them. Notice how many lines we have here, so many more than usual. We have our constructor, which sets all the variables to what they're supposed to be based on what piece we are. We have our getters, and normally we have getters and setters, but we don't have any setters, so we just have getters. We have rotate right, rotate left, and we have a drawing function. And then we end with a whole bunch of curly braces. Cool. And then in our main code, which we haven't really looked at, we can scroll through it. So this is our window size. Remember when I said I thought it was 10 by 20 blocks, and then each block is 40 pixels. This rect size is not going to be used for anything. Can even delete it. Um, Speed is also not being used for anything. I could even delete that. This is copied from an earlier thing. Rectangle position. None of this is doing anything here. Delete it all. The counter is being used. Um, this is left over from earlier assignments. This was if we wanted to get what keys are being pressed on the keyboard. This is new. This is an array list. An array list is how you can make a list of an object, but instead of a regular array, we can use an array list. And the advantage is that it's easier to add things and remove things from an array list, because in a regular array, you have to declare it to be a specific size and it can't change. So these are nicer for us to use. So we're going to use them. So an array list of pieces. Then in the main, we make our window. I'm going to add 7 pieces. So our list is called pieces, and pieces.add will add something to pieces list. And what do we want to add? We want to add a new piece. And then the constructor that we wrote over here, way up here, it needs an X value, a Y value, and a piece type. And here you see X value 1, Y value 2, and then the piece type. It's hard to get this, like it's long, but inside of piece, there was piece type, and inside of piece type, that was actually where the names were. So inside of piece, there is piece type. Inside of piece type, we have these names. So we're going to create an Orange Ricky, a Blue Ricky, a Cleveland Z, a Rhode Island Z, a Hero, a Tiwi, and a Smash Boy. And we're going to put them at different X and Y values so they can all be on the screen at once. Scroll down a little bit. And in this method called update position, I'm adding 1 to a counter. And if the counter gets to 30, I'm resetting the counter to 0. And I'm rotating the pieces left. What is that going to do? Basically, we're running 60 frames per second. So every 30 frames, we're going to rotate the pieces so that the pieces will rotate on their own. All right, let's run it and see if it runs. Uh-oh. Oh, save it. There we go. So this is what we're looking at. So we have all of our pieces and they're all just rotating on their own and we can look at them. So these are the colors that we picked. Some of them were already done, and then some of them we used that color picker to come up with. Like this isn't really red, it was kind of a pinkish. Um, Tiwi, I think, was already done for us, and that was purple. Smash Boy is just sitting there on its own doing nothing. And you can play with this a little bit. You can come up here and, for example, these are X and Y values. So like if you like move these up from 7 to 4, they might be overlapping the other pieces now. Yeah, look at that. They're kind of weird because I moved them up. Um, put them back down. These a little bit. Doesn't really matter where we draw them. Maybe move that up by 2 or something. I don't know. Um, you know, so anyway, we're just drawing them and everything seems to be fine, I think. So the pieces are just rotating on their own, including the Smash Boy, but the Smash Boy doesn't look like it's rotating when you rotate it. And that's it. So that was a lot of work, but we got through it. And I know that this is like a ton to like throw at you for one particular week, but what I'll say is that first of all, a lot of this will make more sense if you um, go through the lecture on Java class fundamentals first. And also, basically every week, we're going to be writing a new class for this project, which means this one might be confusing, but next week, when we're doing almost exactly the same thing, it should make more sense next week, right? So that's how we're going to become more familiar with this. So try it, change the colors, pick what you want, try to follow along, and hopefully it goes okay. Anyway, that's going to be it for now because this was already a long video. So I will talk to you guys later.